Hello and welcome to Tvaritam.AI. In this video, we are going to discuss feature engineering. Feature engineering is an important step in machine learning where we create new features from existing raw features. These engineered features help the model understand patterns in the data more clearly and can often improve the quality of predictions. Instead of relying entirely on the model to discover relationships between the variables, we can sometimes derive meaningful features ourselves using the domain knowledge. This can provide more informative input to the model during the training process. Now, why do we need feature engineering? Well, firstly, it can reduce model complexity and computational cost. If we already know that certain variables interact in a particular way, we can provide that relationship directly rather than expecting the model to learn it from scratch. For example, GDP and population may exist as separate features in a dataset. However, the GDP per capita, which is the ratio of these features, often provides a clear signal for indicators such as Human Development Index. Second is that feature engineering can improve accuracy and robustness because we are incorporating real world domain knowledge into the variables. Another important reason is that some model architectures such as linear regression or tree-based models may struggle to capture complex non-linear relationships between the input variables. So in these cases, feature engineering can help you to explicitly cover these patterns. And finally, it can also help the model to make some hidden patterns explicit, allowing the model to learn more effectively. Type of transformations that are there are mathematical transformations, and one of them is ratio, then product, summation, difference, exponential, log, remainder, and quotient. So in ratio of features, these are useful when relative relationships matter more than the absolute values. For example, debt to income ratio, GDP per capita, profit margin. These ratios often provide more meaningful information than the individual features. Product of features are useful when the combined effect of two variables matter. For example, unit price into quantity sold can give you revenue. Length into width can give you area. If you are predicting the price of a land, the area may be more informative than length and width individually. Summation of features is about combining multiple variables into a single total value that can simplify a problem. For example, total expenses, total score, total trip distance, and if a dataset includes unit cost, taxes, and shipping cost, combining them into a total expense feature can provide a more clear signal. Difference of features is subtracting features to extract meaningful information. For example, revenue minus expenses can give you profit. Temperature difference is useful, age gap is useful. These derived features often directly capture the quantity we are interested in. Others are exponential transformation. So exponential transformation are useful when the data show non-linear growth patterns. These are commonly seen in scientific and real world domains such as exponential increase in reaction rates, population growth, spread of an infectious disease. Exponentials are also used to model activity growth or compound processes. Logarithmic transformations are commonly used when the data is highly skewed, the range of values is very large, the relationship shows diminishing returns. Examples for these are income distributions, website traffic, and scientific measurements. In scientific application, logs are used to model activity decay or compression of large ranges of values. One important limitation is that log transformations cannot be applied to negative values. Remainder or modulo, the remainder operation is useful for identifying cyclical or repeating patterns. So for example, if we divide a number by 7, the remainder can indicate the day of the week. This approach is commonly used for seasonality and cyclic time patterns. Quotient division helps convert continuous values into discrete groups. For example, age groups, income brackets, or time interval. This allows us to categorize continuous data into more interpretable segments. Now moving forward with the implementation, in the feature development tab, you can create new feature using ratio, product, summation, difference, all the ones that we have discussed in the video. So here to show you one example, I'll click on ratio of features and we will select two columns, ratio of revenue and unit sold. So what this will give me? This will create a new feature, revenue per unit, which tells how much revenue is generated for each unit sold. Once we select the transformation and the column, you can just click on apply to generate the new feature. You can go to the analytics base table in the EDA to have a look at the feature. Apart from that, you can also go to conditional analysis to go deeper into the same feature, or if you just want to quickly have a look at the distribution, you can go into transform continuous, ratio revenue unit sold, and you can also have a look at the distribution. So this was about feature development, how you can create new features and look at the distribution, use them in your machine learning model, and then also in feature selection you can drop the features that you had used to create them in case the features are redundant now. Thank you.